Hey guys, welcome back to Computational Biology with Python/Linux. In this video, we're going to finish up our Finding Things video where we find things. So we kind of went through, I forgot a little bit from my last video, but we're going to go through and see how you find things within files, but then we're also going to learn how to search for actual files. So without getting too much in the weeds, let's jump in. Okay, so we're going to open up a terminal again. There we go. Okay, so one thing that I want to go to my correct folder. So we're going to do desktop, classroom, my files, data shell, exercise, that was exercise. Nope. All right. Shell lesson data. Shell lesson data. Then exercise data. Then writing. Okay, that's where mine is. So you want to get to this where we have Haiku, Little Woman, and your thesis backup. So one thing too that we did not do before was that I wanted to include in the last video, but I forgot, was regular expression stuff. And so if we do grep and then a uppercase E, we can, doing the uppercase E tells it that it's regular expression, so don't literally look for these letters. But if we do caret dot O and then haiku, that would mean find anything, any line that has an O in the second position, right? So the second letter in. So as you can see here, it pulled out those words to show us what they are. Hold on a second. So one thing you can do too is there's this software carpentry reg expression cheat sheet, so you can look at what all these different things mean. We did a little bit in a video, but if you're confused or want to make your own regular expression, that's a good place to do it. Okay, so I just wanted to quick add that to the last video. So all right, let's get back out of this. So let's just clear. Let's go. Perfect. Okay, so we want to be in this exercise data. So we want to go back up one folder to exercise data. And if we do find dot enter, it's taking a second. Frozen again. I'm gonna try reconnecting again. I don't know if it's my internet or if Praxis is having a little bit issue today. All right, find dot. Okay, so it did work, and it's just taking its time. So this command might take a time. So find dot, what it does, there we go, is it says, remember dot, just the dot means the current working directory. And so what find does is it searches for files. So grep looks for words within files. Find looks for file names, right? And so find, the output of find is the name of every file and directory under the current working directory. And so this is nice to be able to search for that file that you're looking for, that I kind of talked about in the intro of the last video. And so as you can see, these are everything that is in this exercise data directory. So you can see like protein. So we have a folder here, proteins, and these are all the files that are within that folder. And you can see we have a creatures folder, and then these are all the files that are within it, etc. So let's look at using some options with it. We can do find in the dot, which is this folder. We can do type D. This is being a treasure today. This is one of the things with working with the cloud, is sometimes it can be a little bit, if you're on have a bad day, it's a little frustrating, but bad cloud day. Let's get a brand new terminal, start fresh, terminal number 5. All right, so I have to go back to desktop, classroom, my files, data, some shell, something, exercise, so there we go. All right, I'm back to where I wanted it to be. So if I do find dot type D, this will only give me directories, so it won't give me individual files. So you see I have nothing that ends with like .txt or .anything. These are just the directories or the folders that you may be accustomed to calling them. We can do find dot type type F. So if type D up here is directories, you can guess what type F is. All the files, so it ignores the directories. They still are listed here because the file paths have them. But yeah, so that's how you get to directories. Or excuse me, files, and D is for directories. So now we can search by kind of matching a name. So we say find dot, so in this directory, name, and then we'll say anything.txt. So we get numbers.txt. So you would expect, right, that it would go in, since we did anything with the asterisk.txt, that it would go and find all the files, right? So the problem is that the shell expands wildcard characters like the asterisks before the commands run. So since star.txt in the current directories expands to numbers.txt, the command we actually want to find or to use is find name and then in parentheses. Oops, let's move this. You can see that. Oh, let's move. We need a space here too. There we go. Okay, so now this means find anything that ends with .txt, right? So previously it didn't understand what we're trying to tell it correctly because it ran this before it ran everything else. So now we say, all right, find anything that ends with txt. So that pulls out our txt files. So now let's look at all right, I'm gonna clear this out. So let's do WC L find name. Uh-oh. There we go. Control C. Sometimes there's so many exit commands, I get confused. All right, WC dash L find dot name dot txt. So if you remember, what is WC? If you think back to our previous videos, it's word count, right? So we can say, okay, let's do a word count and then combine that with our next command. See, we use the $sign to say this is a new command for only these txt files, right? So give us a word count for all the txt files is what this is saying. So we have all these txt files, and it says this is how many words are in each of those txt files. So Little Women, which is the whole book, tons of them. Haiku, short amount of words. We made some of these other protein files and stuff in previous videos. Oh man, excuse me. Tell my son was up late last night. I'm tired. So that's our word counts by combining these two outputs, which is kind of cool. So let's do so the way this works is when it sees this command, the first thing it will do is run whatever is in this command, the second command, the one in the parentheses. And then it replaces that with the answer to this, right? So this command is find all the .txt files, right? And then it says, okay, now do a word count for all those txt files that we found previously. So you can do something, if you do like WC-L, and we included these Little Women, Haiku, and Numbers, and if I'm not going to do all of them, but those are the four or the three that we didn't create in the last one. It'll give you a similar thing, right? So we have writing with 11. So this just shows that it goes through and it says, okay, let's name all the text files first, and then it goes back and it says, okay, now let's do word count on all those text files. So you can also use find and grep together. So let's do this grep searching, and then let's make our second command find name there we go. Should be .txt. All right, so think about what this will do. Remember, it does the second command first. So it's going to say find all the text files first, right? In all the folders that we're in or beneath it, recursive within it. And then it's going to say within those, grep searching. And let's actually add to this, to our grep command. Because there's some things that we like to do, right? So we can say, I like the n for, say, give us whatever line number the word searching is in. Do we have anything else? We don't want v because that gives us the opposite, right? We don't care about case. We can put the case sensitive thing in there if you want, I guess. We don't have to worry about words because there's not going to be words. Searching isn't going to be part of a larger word. So let's just run this one. Okay, so it says we have 2 times that we find searching in line 5 of our haiku, with searching comes loss, and then in line 9,276 of Little Women, surprisingly, oh my gosh, sorry, late night last night with the kiddo. 9,276, that line has the word searching. Surprisingly, Little Women has only 1 instance of the word searching within that book. Just seems like it would be, I guess, it's not that common of a word. Maybe, I don't know. It just seems like I would think it would be more than that. But yeah. So if you can find, in this way you can find not only you can specify what type of files to look in or list. So you could actually say this was like a FASTA file. You could say an FA file, look for certain nucleotide sequences or things like that. So it's kind of a more customizable way of searching, combining grep and find. All right, so that is the end. Oh my gosh, it's like 3 yawns in this one. You probably yawn a lot during my videos too, so this is just payback, right? This is the end of finding and searching in the command line through your files. So in the next video, I believe we're going to jump into some Python, actually. We're going to make more Python notebooks and get more into that now that we know how to navigate the command line. This is just a really good tool for computational biology and bioinformatics to be able to move your files around, to know how to look through your files, organize your files, and this is like, get your raw data ready for doing analyses. This is exactly what it is. You're going to have these large text files that have just tons of nucleotides or protein sequences or whatever. This allows you to be able to organize and search through them and figure out what, where stuff is, where you want to put it, etc. So if you're watching on YouTube, please hit like, please hit subscribe. We'll get into Python, I believe, the next video. Fingers crossed. We're very close. If it's not the next video, it'll be the one after that. So thanks again for watching, and I'll catch you in the next video.